So when you're calculating a limit, the first thing you want to be able to check is whether or not you're able to just plug in the value to use the continuity of the function. Because, for example, as you notice, this one that's on the screen involves a square root, right? And all the rest is polynomials. All of those are continuous on their domains. So if I'm able to plug in the value x equals to 2 into this expression and I get a good legitimate number out of it, then that would be the answer. But unfortunately, if you notice, if you plug in x equals to 2 at the denominator of this, you'll get a 2 plus 14, which is a 16. The square root of 16 is 4. 4 minus 4 is 0. So you have something divided by 0. On the top, though, you're going to have 5, and this is going to be 2 minus 2. So that will be 0 on the top as well. So this would be something small divided by something also very small. So this would be an indeterminate result. If we had something small divided by something big, or something big divided by something small, or even a number divided by something small, or something small divided by a number would be okay, but something small divided by something small isn't clear because we don't know for sure which of the small things, the top or the bottom one, is bigger. So we have to manipulate this algebraically. When you have square roots like this, you're going to use conjugates, just like what you did for complex numbers and for other types of radicals that you had in the denominator before. So the first thing you do is you multiply the top and the bottom by the conjugate of the denominator. So this is the original limit. And what you do is you multiply and divide by x, or 4 plus square root x plus 14, which is the conjugate of this guy. And here now you're using, I will use this, the difference of squares. A plus b, a minus b is a squared minus b squared. This is my a, this is my b. So this then becomes, the top is just going to do its thing. The top is just going to have to do its own thing. I'm not going to mess with the top too much because it doesn't really matter, as long as I'm able to calculate the limit. I could, and maybe I will, but I won't mess with it now. I'll focus on the bottom. You know what? I changed my mind. I'll do the top, because that's going to get big anyways. So I'll multiply this by 4 first, use distributive property. This times 4. This gives me a 20. X minus 2, root x minus 14. And then this times this. I can combine these two. Looks like I made a little typo here. This is x plus 14, as you can see. So this is the same thing multiplied twice. It's that thing squared. Since that's a squared, the square and the squared cancel, and I just get 5 x minus 2 x plus 14. And then the bottom, at the bottom, I can use the difference of squares. So this is 4 squared minus root x plus 14 squared, which is just x plus 14. And then I can continue. X goes to 2, and that's going to give me, okay, how can I make this look a little nicer? I don't think there's much I can do other than factor something out. Maybe x minus 2 factors out. So x minus 2 factors out into a 20, root x minus 14, and then a 5 x plus 14. At the bottom will be a 16 minus x plus 14. Note that this is going to be a minus x plus, so it's going to be, let me check that, 16 minus x minus 14, right? Because I have to distribute this minus over. 16 minus x minus 14, so that's minus x plus 2. So that's the same. Repeat the top. Oh, this is minus x minus 2. And that is what allows me to cancel these two out. And now I'm able to plug in 2, because the only reason why this was an issue before was because I had a 0 at the denominator of my function, and I no longer have that because I've canceled this out. Note that there's a minus 1, right? That's always in front of something multiplying it. Always a 1, right? But because of this negative side that I pulled out from the minus x, there's a minus 1 instead of a 1. And now I'm allowed to plug things in, and I will get 20 square root of, sorry, I keep writing minus 14, right? So I'll fix all of those because this is positive 14. So this is positive 14, positive 14. And now I notice that when I plug in 2, so that's 16 plus 5 times 16. So that will be 20 times 4, so 80. And 5 times 16, I think that's also 80. So that's 160. Sorry about the small mistakes, but this is the answer. And this is how you solve this type of problem. As long as you know what you need to do, you can get this one done quickly.